All right. Should be able to hear me. Okay. And you can hear.
Why doesn't it work? Um, hmm. What
All
if
right.
I change it to a big number, then change it?
All right. Y'all
Don't
can
know if this
hear. You
window
can
I'm
hear
talking to is though.
the homies in the stream.
Maybe it's because it's. Hmm. Yeah, at this point, I'm thinking I might just write a test and do it locally on Hardhat to interact.
Is
See
it
how
is
this.
at the problem on the converting it?
Yeah, because I'm trying to figure out. Yeah, so I have the contract and I call it, and the error it's giving me is an unknown account.
Mm-hmm.
And yeah, it's saying it's on the server side, but I'm not sure what that means. So I
It's on
looked
the
at the con.
service.
Yeah. So what I was thinking of doing is using my local hard hat to connect to Mumbai to like call it directly, just so that like, I think it'll be easier to format the bytes.
Like if you just connect with Hardhat, call it, and then just pass on the what that return value.
Yeah.
Oh, also. Oh, wait a minute. No, never mind. I was gonna say to do it through a contract call, but um, you still have to use hard hat to get that private variable.
I wonder if I could do it in Remix. I haven't been on Remix in a while. There we go. 'Cause I think is that a workspace. So oh, why did it just make all this contract? Oh, it just compiled some stuff. What's going on? All right, I'll just make a new one. Let's call this Ethernaut 8. I'm gonna copy this here. And I'm trying to, yep. So I want to load it from, this is the address. Yes, the address. So let's load this one here. Haha, did it. It worked? I think so. So I should be able to see if it's locked. Oh, failed to decode the output. What that means? Hmm. So if I try and send this here, Oh, this is a VM. Let me connect this to my MetaMask. Let's try this now. Yes. Then okay, so this locked is true because this is my level instance. So if I pass in this password here, hey,
Got it?
let's see if it goes through.
Mm.
I think it did.
Hey, let's go.
There it is.
Oh wow.
So now I looked at this level. Oops. I should see. How do we check if you win?
Uh, if you submit it and then yeah.
Oh, there we go. Submit.
If that
Oh,
thing clears, I'm about to be phoning you whenever I get to that challenge. Let's
hey, there we go.
go. Good stuff.
Nice.
Awesome. Yeah, it's one of my favorite. I love
Hey, can you
reading
hear me?
like this. Hey, how's it
Hey,
going?
what's up? This is Robinson, right?
Hey, what's going on? Yeah, this me.
What's up? What's up?
Yes, sir. Not much.
You just hopped in at the end of one of the CTFs.
Okay. Oh man, no worries.
Cool.
So when is the next one?
Uh, the next CTF, so I think there's the info session for courses on the 30th. Um,
Okay.
next CTF, I'm not sure. I might do the same one again, but on my local hard hat, just to like have a test to do it. But yeah, I
Yeah, and
also want to
I'm.
go to the audit.
Oh, you about to go to auto report too?
Yeah.
Oh, bet. Yeah, I'm about to. Shoot, I might have to tune in on that one. I was about to go to the delegation challenge. Uh,
Oh, right.
but what I'll do is I'm gonna get an update. I'm gonna get an update. I'll pop in.
Cool.
Which report you going through?
You said
Huh?
I was gonna go through um either the one that you sent or there was another Sherlock audit report that just came out.
Gotcha.
Yeah. Cool. Right, I'm gonna hop off for like 3 or 4 minutes to get some water.
Cool, cool. Catch you
Uh,
back. I'll be
cool.
on the delegation one while you're gone. So once you get in and start up the audit report. If you take a break during the audit report, I might ask you for help, or
Awesome.
either of y'all for help. So uh, yeah,
Cool.
let me so deafen myself. Okay, is all right. So when Robert comes back in, I'll deafen myself so you don't hear the cross chatter. Um,
Mm-hmm.
but I'll just walk through as a because I'm also streaming both on YouTube and this. So
Okay. Oh, you have a YouTube channel?
yeah, yeah, I'm starting to stream. I stream all my study sessions.
Okay.
Yeah, I'll share it. So that way, if you want to catch up on any of the CTF challenges, I have like me struggling through
Awesome.
everything. Yeah.
Oh, you can send it that way.
Yeah, it's just the same as my name.
Oh, okay. I'll become a follower,
Thank you, thank you.
and I'll get the likes up too.
Cool. Thank you.
You're welcome.
All right, so also let me just test real quick. Once I come in, I'm gonna deafen myself and do this. Y'all can't hear me. Okay. All right, bet.
Yeah.
Y'all couldn't hear me just then, right?
Yeah.
All right, cool. That's what I'm gonna do when Robert gets back. All right. So the goal of this level is for you to claim ownership of the instance you are given. Things that might help: looking into Lee's documentation, delegate call, or level functions. All right, fallback methods and method IDs. So the first thing I'm gonna do is, well, let's go ahead and get a new instance. And then I usually like to copy everything in a hard hat because I do stuff through there to try to
Okay.
simulate like a real attacker.
Gotcha.
So let's go here. Should have a new instance. I don't know why I don't yet, but all good. It's called delegate. Delegation. All right. So now what we're gonna do is, and also let me know when Robert gets back so I can mute myself, so
Okay.
that just the YouTube channel here. All right. So now what we're gonna do is do some reformatting. So let's take out the delegation. Yo, I still didn't get my instance yet.
How long do you usually do these sessions?
I usually do them for like 2 to 3 hours. I try to do no more than 2 hours at a time.
Okay.
It gets pretty long after two, but I try to do 2 hours, and then if I can get like 2 challenges in, that's perfect. Instance. Bro. Okay, well, looks like I'm not having no luck with yeah. I don't know what's going on. Let's see if I refresh. Level address, player address, okay. Um, there we go. Okay, now that should come in. Actually, let me throw y'all over here. All right, so we got our instance address, and we have this contract. So it looks like This is going to be an attack from an externally owned account, so a MetaMask wallet. I would prefer to do that instead of using delegation. Instead of using an attack contract, because it kind of already sets it up for me. So we have this code. We're going to change this to delegation. Then we're going to change this out. Oh, wait, no, just delegate. Okay. Yeah, I'll leave it as this. And then what we're gonna do is, and for anybody in the who joins the YouTube, I think I see someone in now. You can join us in the Discord if you like. Um,
That's me.
oh, cool. uh, so all right, here's what we're gonna do. First, I'm just gonna approach it like the eye of an auditor and just see what's up. So we know that, and I should be studying up more on delegations, but basically, delegate calls allow you to call another contract with you essentially as like I won't say the owner, but it allows you to call a contract. So it allows you to call this contract B, and you can change the state of its own contract. It's kind of weird, but basically, this is contract A, this is contract B. If you set up the state to have the same format of contract A, basically when you make this delegate call, you can change the contract that you're making the delegate call from. It's very weird, and I kind of still don't understand why the heck they like the founders made it this way. But stuff like this is like error prone, and it's definitely easy to do a lot of attacks with this if it's not set up right. Um,
Oh, and Robert came back, just so you know.
oh, bet. All right, Robert, you back in?
Yeah. What's up?
All right. I'm going to mute myself and continue. But yeah. Hey, I see Matthias is in too. What's going on, Matthias?
Hey, what's going on?
This is the Web3
Hey,
squad. We bringing everybody in, study, learn.
I just saw the I just saw your comment on Twitter, and this looks super interesting. What are we up to now?
Yeah, so what I'm doing is I'm going through CTF challenge on Ethernaut, and then Robert's about to go through a code for or Sherlock report. Um, and so yeah, we're just going through different stuff. Everybody's in here studying what they want to study or just listening in if they want to. Um, yeah, just a place for anybody in Web3 who just want to come together, learn, and study like a big study hall.
And can we share multiple screens?
Yeah, I'm sharing mine right now, I think.
Okay.
Yeah,
Share mine.
and I'm gonna take my so I can lose. Yep. So everybody can just share what they're studying, and let me also just cut out that way it just doesn't take up a lot of my space. There we go. All right, so what I'm about to do is I'm gonna mute myself, and I'll still show my screen so you can follow along with me or tune in on the YouTube side to hear what I'm saying. But I'll come back in and chat while you're doing the stuff on code for Robert.
Sounds good. Yeah, I may. I don't know if this one has a report yet. Let me see what their last actual audit report is. So judging.
Okay. So I believe. Okay. So back on YouTube, you all should be able to still hear me. And I'll tune in to what Robert's doing in a little bit. But I'm gonna spend some time going through this challenge really quick. So let's see. Also, let me hit up Matthias real quick. All right. All right. So wait a minute. Why is that? Oh, definitely to everybody.
Just looking at this audit that happened here, and
All right. Mm-mm-mm. Okay, so sorry, y'all. I'm over here chatting with a friend, catching up in the Discord. Okay, so with this, ooh, I should just put on music whenever I step away. But yeah, let me step away for like 2 seconds, and then we'll get back to it. About to throw on some tunes to chill out to.
What are you staring at me for? Okay, I'm back. Let's go ahead and get right back into it. So, with this delegate contract, I think what I was trying to explain before was that with delegate call, basically, if A calls B, what that really can do is change data inside of A. It's kind of weird, but that's what delegate call allows. Um, so with this solution, it's a little interesting because, and this honestly may be wrong about it, but um, what I think is supposed to happen is that I call this fallback function, and what I do is pass in message.data with this function signature, which is this right here. I'd pass it in with this function signature and telling it what I want it to do, which is actually, I don't think I need much. I think I just need to pass in the function signature. There's no arguments or whatever. I literally just pass that in and I should become the new owner. That's my theory. So let's test it out. So we're going to do an attack delegation or attack delegate call. And our instance address is the instance address. Yeah, our instance address is this right here. So what we're gonna do is paste it right here. Oops. And then we want our delegation contract. Okay, so we have an attacker, we have a contract address, and we don't have a balance, but we're gonna have a owner or new owner. So delegation contract connected. for this attack flow, what I want to do is first see the original owner of the delegate contract. Okay. And then what I want to do. And then what I want to do is, so after I see the owner, I want to call the fallback function of delegation contract. Okay, because that's the delegate call. That's where the exploit happens. And then after this transaction, we want to grab the new owner of the delegation contract. Okay. And so at the end of this all, we want the attacker address, or let's say we want the new owner of the contract to be equal to attacker.address, because that's essentially my account. I'm the attacker, I'm the hacker. So let's say confirming. Oh, let's confirm that we have. Let's confirm that we have. Let's confirm that we have gained ownership of the delegation contract. Okay, so that is the flow of the attack. Now the only thing is we must execute it, and this is where it gets interesting. So we have our hard hat. Let's go ahead and configure that to be the same as this pragma. Now, the interesting thing is, I know that with a fallback, we have to make a call. So there's two things. A receive function takes message.value with no data, and fallback takes message.data with no message.value. Okay, so I believe that's how it works. And what I want to do is, what I do? All right, so what I want to do is invoke this fallback function. So how do I do that? I believe we just create a, so let's take it from the top. Let delegation contract equals await contract at delegation. And then we're going to connect that. And then let's see the original owner. So original owner is going to be equal to await delegation contract dot, no, delegation contract dot owner. I believe that's how you call that one. But what we should do first before anything is just compile. Make sure we can compile this. So I'm gonna switch to Node version 16, and then I'm gonna say compile. And obviously we do not need anything in here because I'm not gonna make an exploit. I'm not gonna make an exploit contract. I'm gonna do this all via a transaction. So let's run this again. 2 files compiled successfully. Now we can read the ABI. So let's go ahead and get this. I gotta clear this actually. Hardhat clean. Now let's compile. All right. So we get our contracts. We have our delegation. We have two contract ABIs in here. We have the delegate and the delegation one. So there's two things we need to focus on. This owner right here. So we can call this Yep. So essentially, because these contracts are set up to look with the same data structure, address public owner, that means we can make this attack. But first, I need to check who the owner is first. So let's do that here. We're gonna we are going to grab the original owner, delegate contract owner, and that is the name of it. Yeah. So it's going to be owner. Of the CTA. What's the CTA, Matthias? The contract address? Contract. Oh, so like of anyone watching? Um, so yeah, so basically this is set up to either follow along with me or study something else. So um so basically what I'm trying to do is exploit this delegate or delegation contract. And if I get stuck, I definitely will be like, hey, if you're in the chat or in the audience, then definitely help me out. And then if not, then follow along, watch, just whatever you're feeling at the moment. I would be in the Discord so you can hear me, but I think Robert is presenting right now. Oh wait, he's not presenting. Hold on. Let me go back in the Discord so you can hear me. Really quick. Hold on. Let me go back in the Discord so you can hear me. Hey
Yeah,
guys,
he said he's off.
is Robert gone?
Yeah, he said he's gonna step away. He put it in the chat. If he's
Oh,
hey guys, he said he's off.
is okay.
Robert gone? Yeah, he said he's gonna step away. He put it in the chat. If he's
Oh,
hey guys, he said he's
all right. And Matthias, can you can you tune out of the YouTube chat? My bad.
put it in the chat. Oh, hey guys, he said he's
All right. And Matthias, can you can you tune out of the YouTube chat? My bad.
oh, hey
Can I
guys.
do what?
All right. And Matthias, can you tune out of the YouTube chat? My bad.
Oh, hey
I'm
guys.
going.
And Matthias, can you I'll mute him if not. All right. All right, we're all good now. Okay, so basically, yeah, Matthias, you can come out of the YouTube chat if you want now, since we're all back in here. This will be the primary place where I talk and stream, and then anybody on turn my camera. Anybody on YouTube will just be able to like hear us talk, hear us chatter about stuff, but they'll watch us through the whole thing. Um, so what were you referring to when you were saying the CTA? Oh, you're good for the echo, Matthias.
I'm sorry. I'm
Oh, you're good for the echo.
I'm super confused. I'm listening like 100 voices.
So you can exit out of the YouTube since we're back. We'll be in the Discord. Just come to the Discord and you can see me
All right, so
streaming in here.
we're in YouTube, right? So, okay.
There you go. Yeah, so basically the YouTube is for like is for anyone who comes back later and they're like, hey, I saw you do this thing and I saw you interact with people, saw the conversation. So we don't have to be in it. Like we can be all in here now. And then it's also for if like say we do this tomorrow and then Matthias, you wanna showcase something or walk through something, get help with anything. You can be the main one in this chat and then I'll just mute myself and go to the YouTube so that way anyone who was just following along with me to walk through like the CTF, then they'll still have that video for them. And then after I get done with the CTF, I'll come in the chat and they'll see us all talk about whatever we're learning in security that day, what we're struggling with. Yeah. So basically what I was saying was you said in the chat, what's the goal of the CTA? What's CTA?
Of this exercise. I mean,
Gotcha. Yeah, so this one is this is the delegation challenge. The idea is, let me scroll down. Step back. So basically we're supposed to be learning about delegate call. I should I should go to the Solidity docs and read this over so that anyone in the future can see, but what I'm gonna do for now is link the docs in the YouTube chat just in case anybody wants to see it. And I'll also link it in this chat too. But I think I have a general understanding of delegate call. And what I'm gonna do is just test my theories on it. And then if I struggle with it, I'll go back to these docs and also just ask you all. But from my understanding, there's a interesting way the delegate call works. So I kind of mapped it out here. Let's say you have contract A, which is this right here, and it makes a delegate call to contract B. Essentially what you're doing is, as long as contract A has the same data structure, like it's stored everything in the same manner, you could actually modify contract A with a delegate call to contract B. So how I think we're supposed to complete this challenge is we're gonna call this fallback function, and so we'll talk about that in a second, but we're gonna call this fallback function that's gonna make a delegate call to contract B. But the caveat is that we're actually modifying the state of contract A, which is going to allow us to successfully hack this challenge. So that's my theory. And funny enough, the person who taught me how to do like certain pseudocode setup for POCs is in this chat is Matthias. So basically what I like to do now is to set up my attack, we have to pseudocode it out. So first I said that we want to see who the original owner of the contract is. And then we want to make the fallback function. We want to invoke the fallback function that's going to make a delegate call. All right, this is where the exploit's going to happen. And then lastly, we want to grab the new owner of this contract. And then we want to make sure that we are indeed the new owner of the contract. That would be a successful exploit. So this is my template. And then what I like to do is just go step by step. And I'm obviously not going to be able to do this in the first try, but by the end of by the end of this hour, I should be able to successfully hack it. So that's the objective, and that's kind of the layout of what this challenge is and how I think the approach is. But we'll see if I'm correct. I could be wrong. So
good work, sir.
thank you. All right, so the first thing we're gonna do, we have everything connected. So we have our attackers signer address set up. We have the attack address. So this is the contract I'm going to exploit. We connect to it, and then this is just to verify that we're connected. So let's go ahead and do, I think it's called a string literal. Forgot the proper term for this, but we're going to check if this is connected. And then let's grab this original owner, which should be whoever deployed this contract. And then the next step is we're going to call this. Okay, so I don't know if I covered this before I came off mute, but I'll go back to it. So another key part of this is learning how to invoke the fallback function. So there's two functions that are like special functions in a lot of Solidity programs. So you have this receive function, and you have a fallback function. I probably did not say this correctly, but is that how you do it? External payable, not unique. That's essentially how it's supposed to look. Yeah, that's essentially how it's supposed to look. I don't know why it's bugging right now, but the idea is the receive function allows you to receive tokens, and then your fallback function allows you to receive like special data. So how I like to view these is if someone sends your contract money without specifying where which function it's going into, it's going to hit your receive function. And then if someone specifies a like for instance a function it wants to call, but it doesn't like send you any message.value, then that's going to hit your fallback function. So let's actually validate how to invoke the fallback. Just queue on call with empty call data. Okay, so the receive is for empty call data. Yep. And then no such function exists. Fallback function exists. This will be called on. Yeah, fallback. If no other functions match the given function signature. Okay, this actually helps me a lot. Perfect. So what I'm gonna try to do is call this fallback, and remember, I'm not gonna specify like any function signature in my call. I'm just gonna pass in. I'm gonna call this contract with data that should be this function signature. That's how I believe this should go. Message value. Test. Okay. So I think it should look like this. All right, let's just code and see where we get to. Okay, so we first grab the owner, so delegation contract owner, and we're gonna output that. And then next we're gonna make a transaction fallback call. And how should this look? This should be, we're gonna do something like await ethers.send. Is it send transaction? What you throw in the chat? I'll have to drop off as well. I'll catch you later, Robinson.
All right, so I think this should be. Is it attacker.send? Nope. All right, let's check the hard hat. Signer.send transaction. Let's look at the docs. What if we just want to send data? Ethers.
Have you, Mike?
Hmm?
Have you sent Ether between accounts in the past?
Yes, I did it on I had to do it for one of the last ones. I forgot which one it was. I think it was fallback. Yeah, the fallback challenge, I had to do it there.
This is the same idea. The difference is that you have to fulfill the data field.
Field. So on Ethers.js though, why am I only seeing the I'm not seeing the data field. I'm only seeing the message value.
Message value is the data. Go to the if you can go to the to Antonopoulos Mastering Ethereum book. No, just Mastering Ethereum.
Right here.
Transactions. Scroll down. Keep scrolling. Just keep scrolling. Keep scrolling. And at some
Send
point, you're going to see
transaction. Ah, this right here.
right transaction. Keep scrolling. Right. The data. You have to give a shape to the transaction. So the data, you have to fill the data. If in the case of fallback, the fallback function is triggered when you send a transaction, which in the data part, the function signature doesn't match with anything.
Yeah. And that's what we're supposed to do here is in this call.
That send transaction to value, and that in that to value, the data part is the one that you want to follow.
So we just use data. And then we want to do ABI encode, I think.
I cannot really remember what is, but yeah.
And then we want to send the function signature of this call right here. And good thing
Solidity Visual Developer allows you to get that already. Okay, so I've got the function signature. And we're going to, I think this is not it. It's ABI, it's ethers.abi. Oh,
That you have something like right, central section, there is like right. Forget about it. Keep going.
there we go. Oh, I think I can just do my address 558. No, I don't want that. How do we encode a function signature in Hardhat? There we go.
I have an assumption.
What's up?
So the ABA encode, what it does is that it takes the hash of the signature and then fulfills the first H bytes.
Mm-hmm.
And after that, it's going to call the corresponding function. But if you the first eight bytes you put them like strike zeros, you are going to trigger the fallback function.
If you said for the first bytes you do zeros?
The strike zeros, yeah, right. Because that is not going to match anything. So on the fallback, the message data. Oh, just give me a second. All right. The thing is that you need to serialize the delegate that bound function as the message data.
I need to say that again?
You have two contracts, right? You have
Uh-huh.
the delegate contract and the delegation contract. The delegate contract has a bound function, bound public, right?
Yes, yeah. So we're trying to call this function signature.
There is I think that in ethers.js there is a populate transaction, I guess. I think populate something, right? If you take, for example, the delegate contract into the JavaScript code.
If we do say that again, if we do,
Can you go to the JavaScript code?
yeah.
JavaScript, right in there. Instead of provider, can you take the delegate contract from somewhere? Right? I think that you can do that.
Yeah, so the delegate contract is going to be this. Oh, wait, we're going to use this contract address, this right here. That's the to address.
That's the delegation contract. Instead of delegation contract, cast the delegate contract in data, or really like just above that. Scroll a little bit up there. In the line 12, you are creating a delegation.
Delegation contract? Yeah.
No, go back to you there. In line 12, you are creating a delegation contract object, right?
Mm-hmm.
Create the same object, but for delegate contract, not delegation contract. Like in the line 7, create a delegate contract. Let
So how do I? The thing is, though, it's all in one contract.
no when right delegate contract and then paste the. If you can create an instance of delegate contract and then have the palm. No, forget about it. Just keep doing as you are doing. The thing is that in the same way that you are doing, go back there. In the same way that you are doing in the line 12,
Mm-hmm.
if you can create the same artifact for delegate contract, like the delegate contract takes just one owner, right? There, like a delegate contract equals await ethers.js get contract at,
And it's still going to
and
be
you
at
need
the contract address.
and you need the address, I guess. Delegate contract, delegate. Yeah, right. And the address. Yeah, I don't know if the same address. It's not the same address. It's not going to be the same address because even if you create the contract from another contract, you are going to have another address.
Yeah. Yeah, I don't know what that other address is just yet. What I'm gonna do, what I want to try to do first is just send first figure out the function figure out the function definition and try to encode that and just send that first and then see what that does.
Well,
Yeah. I just need to figure out now how to just invoking the invoke the fallback function. Yes, Tremaine, you can. Thanks for joining in, man. Have a good one.
You too. Have a good night.
Thank you, thank you.
All right.
There we go. So this is going to invoke the fallback function, call it data, and it's going to be this. Oh, that's it. So I just have to do this right here.
that's what I was telling you. If you send a 0, but the problem is that you need is you anyway you need to send some data,
Yeah.
I guess, or not. Let me take a look.
You need the signature. You need the function signature.
All right, you don't need that.
Yes.
You need data. You need to send some data because in the delegate call you are going to send for meshes data. So you need to have the function signature for delegate.bound.
Yeah. So all I need to do is I have to figure out how to ABI encode with with Hardhat.
Yeah, I think I have something like that for this.
ABI and code packed.
No, this is what I'm talking. I'm going to send you the link of an example.
Okay.
So this goes on Telegram.
Yeah, you can put this. Oh, you putting this in Telegram?
There you have it.
Does that have the answer?
No, it's a hint. It's not the answer.
Okay. I'm like, I can't do that.
Try that. Let's try that answer. No, it's not the answer. It's just a way that make you understand how what it was asking you to. Yeah, there is. Uh, there is like contract that public transaction that withdraw, right?
Yeah.
And that contract is that is the artifact that you want. I want you to create.
Got you.
If you
Got you.
there, take a look back out there. The contract. Can you scroll up a little bit?
Yeah. I see what you're saying. So grab that contract, right? And then populate
Create, yeah.
transaction, and that's going to give you the the data for that function.
That's it.
I got you.
That's it.
Isn't there but there's an alternate way to do it, right? You can do it by just grabbing the function signature and encoding
You
this
can
data.
you can calculate the hash and then take the first H bytes, and you can do that manually because that is basically the data for the transaction, like just the H first bytes. But it's easier if you cast the contract from somewhere.
I got you. So get the contract and then call this withdraw
The
data.
contract is up there. Forget about lot fee. Scroll a little bit up there. Just keep scrolling, keep scrolling, keep scrolling.
Oh.
There it is. Fixture, keep scrolling, keep scrolling. Just keep scrolling.
Yeah.
Oh, there it is. And H you need to have that artifact, or you can calculate the hatch. Let me go for example to calculate the hatch manually. Maybe that is easier.
Yeah, let's just try it. Where we at? Also, I need to learn how to use this. I need to get more familiar with Kekak and like how does this part even work too.
Yeah, I'm going to send you. I'll send you an example of how to do this manually. I have this somewhere. Like just to take the function signature, calculate the hash, take the first eight bytes, and you are going to be good to go. First, that's I have the solution in here. Oh no. Let me see the telephone data. Yeah, I got it.
Talking about this right here. Does it look like this?
Or is this is kind of part of the solution? This is a code that I did decades ago. Take a look at that.
Is it the answer?
Is not the answer. Is how to calculate the data payload. It's not the answer, man. It's not the answer. But it's going to calculate the data. Don't be
Okay,
afraid.
got you. All right, let's check it out. To get that slice. This.
You see, so you calculate the hatch of the function, which is PWN, and you take the first 8 bytes. The signature is just going to be the signature.
Yeah. What's the different? The this is the this is basically the answer. But
Not me, not
yeah,
completely.
this
I'm just hinting you the way to calculate the hatch, the payload.
got you. So debug. Where does debug Ethernaut come from?
Now don't take in count that debug Ethernaut. That is a function
Yes,
that's called a debug function to bring things into the console.
got you.
The
So I already have the
payload
function signature. I just need to do this piece right here. The
data, you don't need the data. You can send empty data.
say that again. Because this
You
is
can
the
send empty data. You can send like without any data. Can you go back to the contract into Ethernaut?
yeah. Into did not. So we got this right. Yep.
Your first step, right? So if you take a look at the PWN function, it's going to take the message sender. It's not taking into account the data, but the data has to be well formed.
Yeah.
But if you send the data in the data, you're seeing only the signature is going to trigger PWN.
Yeah. So I may just be able to do this. Because that is the function signature that I want to call.
Right. Because the data, the first H bytes marks or indicates which function you want to call. And the next bytes marks what are the parameters for that function. But that function does not receive any parameters. So if you only send the function signature, you are going to trigger that transaction, that function.
That function, yeah. Now, what if this were to have, if this were to have, like, let's say I had to have like an integer, I have to pass in data inside of it. That's where I would have to do the kickhack.abi part, right? And you have to do the signature along with, if it's a uint, you know what I'm saying, like the arguments.
Right. Nothing's going to happen because the function is not expecting any parameter. You can send
You could just send.
many. You can send as many. Right. The function signature depends on the function selector depends on the signature. So, can you go back to my example?
Yeah. Which one? Where was it? Here? Nope. Here?
The code I sent you,
Yeah, this right here.
right? That is calculating if a signature of a function called PWN, all right, without any parameter. So that is the correct way to cast PWN, because PWN is not specing any parameter.
Yeah. Got you. But this should still work though, all right? Or we could try it. Try it out and see. Okay, and we're gonna do delegation. Oh, that's why. It's ELA. Attack delegation. Uh, What did I do the balance? I did not mean to do that.
I think that you don't have a signer parameter. That's why it's saying
I don't have a what parameter?
signer is not defined anywhere, I guess. In the 931, you have await signer that's something, and signer is not defined anywhere.
Oh. An attacker. There we go. Thank you. Oh. Okay.
I think you need to add a OX 0x before that. Not yeah. Go back there in the data 0x. Try again.
Yeah, I wonder
Try going.
why. I wonder why when we grab it from here, it doesn't automatically give you that function signature. When we grab it from the actual contract. But let's give it a shot. Ooh. So it sends the data, but the
Like if your test is correctly implemented, your assertion, the after, all right, new owner to be to it attacking
attacker
that, and
address.
is the delegation contract that owner. Is that correct? Is not the delegate instead of the delegation?
You say it's not the. It should be the delegate.
Yeah, because I think that the goal of this CTA is to change the owner of delegate con, right?
I thought it was of delegation. You're given of the instance you're given, and
Yeah, maybe you're right. I'm sorry.
yeah, let's
What if
check
we
out
try?
let's check out
What if
the
we try? What if we try uh, with the web browser console, like right in there, like right in place, instead of your VS Code, try it from the console.
oh, it just ran out of gas.
Contract execute and complete that.
I've never seen a call like this where it's partial, like it says it's a success. I would do it in the console, Matthias, but um I feel like I want to do it like an attacker would. I want to do it straight from Hardhat, straight from the code.
Is your session.
Let's see, gas limit. Let's see if that works. But no, I see what you mean. I usually would try it, but lately, so what I've been trying to do is force myself to do it through Hardhat so that I go through intrinsic gas too low. So that I pretty
Yeah.
much do it in a manner where I learn Hardhat, I learn like Web3.js, um, all that.
Honestly, I don't think the gas is the problem.
It's this data right here. There we go.
I don't know if I don't know if it's the data, but I don't think it's the gas because
We worked. Yeah, it was a
yeah,
guess.
it was the gas.
Yeah.
It
All
was the
right.
gas. Right. You hacked it.
Nice. Thanks, Matthias.
Right.
Thank you. Thank you. That was fun. Um, the crazy thing is though, I think a lesson learned is I need to learn Web3.js for ABI encoded data and function signatures.
Stick to it. Ether.js is easier.
You say you use ethers.js?
Yes, yeah. Web3.js is a raw implementation of the Ethereum functions. But in Ether.js, you have the populate transaction function that gives you the whole signature. In Ether.js, indeed, if you can go to the Ether.js documentation,
Mm-hmm. I think I
like to
had it up. I thought I had it up
homepage,
earlier, but
to the homepage of Ether.js,
Yeah.
Can you go in there? Right, documentation, the homepage, like there is in features. Um, no, in the where you were, right where you were in the previous page. Right there in features, there you are going to see the differences between using Web3.js and using Ether.js. The difference is that Web3.js is, if you want to implement something like raw, like manually, everything, you are going to, you can Web3.js, but Ether.js wraps up a lot of things.
Yeah.
It even wraps up like ENS, uh, wraps up many things. So Ether.js, whenever you have a contract, you have this function which is called populate transaction,
Mm-hmm.
which give you the data. And honestly, the only times that I've used that, like populate transaction, was when I was when I was playing around with this
Yeah. You,
Ethernaut
so you never really have to
CDN.
use it whenever like you're building like real Solidity smart contracts. Like that rarely happens, huh?
Right. The thing is that when you work with Hardhat, there is a plugin called I cannot
Waffle.
really remember
Waffle.
what.
Is it
Which one?
Ether's
Which one?
Ether's waffle? Is that the one?
No, Waffle is for testing. Is called Sidechain. Can you go to Google?
Type chain?
Chain.
Type chain ethers.
Chain Ether. Perfect. No, it's not that. It's called
It's
Sidechain
probably this.
without
Probably this right here.
without the. No, it's not part of Ethers. That yes, it's that one. Go in there. Go in there. Then go to the repository. The to the left, to the right. I mean,
Where is it
where it
at?
says
Oh,
to the right, to the right. Uh, to the right there. Go into the repository up there, or maybe in there. I mean, yeah, Typechain. This is a you can implement this plugin into Hardhat projects, and what it's going to give you is like an easy way to interact with your contracts.
nice.
This is a this wraps up Ethernet.js, which wraps up Web3.
Web3 JS.
Right. And maybe we can have a session to how to use Typechain to
Yeah.
make things easier, because with Hardhat it's super easy to implement extensions.
Yeah.
But yeah,
No. That.
yeah, and that this session was great. Sorry for interrupt you so much.
No.
Uh,
That's what this is for. This is for all my friends to come in, help each other, like literally debate stuff, go through stuff, because I mean, you taught me something new. Like I was stuck on at least trying to get it this way, and then if it didn't work, I was gonna try your way. But that's what I like about. I love this about CTF challenges and just solving problems, because, like, I was like, okay, I think I can do it this way, and then you're like, hey, there's also another way you can do it, and so that's a completely new way. So like, I'm gonna note that down. But yeah, that's what this is for. Like, you're supposed to chime in, you're supposed to interrupt, you're supposed to do all that. So yeah, don't see it as like a bad thing.
the interesting thing is that can you go back to your JavaScript code?
Yeah. Hold on, let me throw down the let me just throw down a few notes. I'd like to take down a few things
Or
right after I finish. Let's
when you try to develop front-end code for a smart contract, many times you have to say contract that uh, function, and you open the parentheses and you don't really understand which parameters are you sending out. For example, if you go, I don't know if you have any property here. Imagine that that owner function in the line 27 expects some parameters,
Uh-huh.
right? Because it's not expecting any parameter. That owner is just going to give you the owner, right?
Yeah.
But that owner function is indeed a function of the contract, right?
Yep.
With the delegation contract, you can say, for example, imagine that you want to transfer something or you want to approve something, right?
Uh-huh.
If you go that approve, you open the parameters, and if you don't use type chain or if you don't use TypeScript, you you are going to constantly going back and forth to the contract to know which parameters this function expects, right?
Uh-huh.
With type chain is going to create a um, group of types. It's going to create a group of structs, and it's going to tell you like the first parameters is a, I don't know, a number. The second parameters is a, I don't know, an address.
Yeah.
The third parameter is an array, right? And
Yeah.
when you develop front end, that is super useful. Indeed that is a bless.
Yeah, that's a good point because I actually have a TypeScript audit coming up, and I was thinking that I should do this all in TypeScript. That way, I learn like what types this stuff is actually gonna be before I send it off. And it's also, like you said, it's good for the front end side, which is why I personally like Hardhat right now, and why I'm gonna transition to Foundry later is because like if I want to build a front end part of it, I need to know how to interact with the code.
Not only that, if you want to create a test, for example, and you have a function that maybe that you have a function that for some reason you need to add another parameter or you need to change the order of the parameters,
Yeah.
right? And you run your test. If you don't have type chain like gives you an interface of this is what your contract looks like into blockchain. So if you change something, it's going to tell you like in JavaScript, like your interface has changed. So you have to change these things instead of guessing. It will be, I think it will be super useful for us to have a session where we implement like Hardhat with TypeScript,
Yeah.
and we add type chain, and you are going to see how fast you move by using TypeScript.
Yeah, that's a good point. I think I may have. Did I do that? I don't think I did. In Patrick Collins' course, I think I may have done it, but I can't
I think we do,
remember.
right?
Say it again.
Patrick, the guy that was working on chain, right?
Yeah, Chainlink. Yeah,
Yeah, he's using Python heavily.
yeah, he does. But he also did a. Is this it? He also did a course. He revamped that. He did a course where he did it with Hardhat JS. When he first got into the space, I think he said he did it heavily with is this it? I think I did it typed. I think I used type chain in this one.
Chain types. Yeah, that is the folder that it creates when you work on it.
Yeah.
Uh, go to that folder. Go to that folder. It's going to be super interesting for you to understand how it happens. Yeah, right. You are going to have all that aggregator interface, common interface, me. Though all of those are contracts, but typechain creates the TypeScript interfaces for you to know that if you want to call this function, for
Mm-hmm.
example, get timestamp, right? It expects in the line 33 in get timestamp,
Yeah.
it is going to return you a big number. So you
Okay.
know what is going to return value for that,
Yeah.
which you don't have to worry with that. Can you scroll down a little bit? Maybe you have some function that has the parameters for that. Go back to there, or to factories. I think in factories is more interesting. Um, functions, um, for example, no, go back to where you were, like to aggregator interface, for example, to the right into your. The thing is that I think I'm just confusing you with these kind of things.
No, no, no.
Um,
Actually, this is good because I when I did this course and he pretty much had us install type chain. I was like, what is this doing? And this is good that we're going through it because I didn't know what it was doing. I was just implementing it and then running with it.
yeah,
So now I know what's happening.
I'm just going to sound too old for this, but when I started creating my own contracts, when I started learning Solidity and writing the test, for example, if I was going to create a function, um, the thing is that I was going to call like web3.js that contract that whatever contract name that the address that um, tone or method. Yeah, that is the big thing. Method that guess the name of the function first. Like guess, like if you want to call the whatever name in your contract, like you have to guess the name of the contract, and then you open the parentheses, and then you have to type the parameters right without having any hint. And
Wow.
the goal of type chain is that you are going to have interfaces for you to, like, you have that contract from your solidity code, is going to create interfaces for you. It's
Mm-hmm.
going to take all the functions that you have, and for all the functions is going to give you, like, okay, if you're going to call the function set value, you you go in, like, the artifact, like, I don't know, my contract that uh, function, and you open the parentheses, and it's going to tell you, okay, the first parameter is a number, the second parameter is an address, the third parameter is a something, and it's going to tell you even the name. And that is the big magic of type chain. Is a pretty useful tool, and I don't know how much people know about this.
Yeah.
The last time I used this, I was working with a company that we were developing some contracts, and I tell them that this is time that is worth to spend implementing type chain, because it's going to help us identify super easy what are our problems. Because right now, if you, I don't know if you remember that right now you sent some data and it told you that the data is wrong, right?
Mm-hmm.
Before you insert the 0x, it told you that the data is wrong. But imagine that for a function that expects like 4 parameters, and it only tells you that the data is wrong, but it does not.
And tell you
It's not
where,
going to.
like right here, this hexafly when it told you that the invalid hexafly.
Right there. The argument value is invalid argument, and you don't know you don't know why it's invalid.
Yeah.
Maybe, and then at some point is that it's only that you deleted one value, you deleted one letter,
Mm-hmm.
um, and that is the big thing about type chain.
Yeah. Yeah. Yeah, no, that's cool. I think it's definitely someone had joined in. I thought I could have sworn I just saw
Yeah,
someone was in here. I guess he dropped
right.
out. Um
Yeah,
but
maybe
yeah.
for we can run through creating a simple contract using type chain.
Mm-hmm.
Uh, and you'll see the difference between like going through ether.js and calling get contract add, and then trying to call a method without knowing the parameters, and then using type chain that's going to tell you the first parameter is a number, the second parameter is an address, and is quite clear.
Yeah. Yeah, no, we should definitely do that. So what I'm gonna do is, I mean, for these next sessions, so how I typically do it is, 1 week I focus on CTFs, so like just going through the CTF, solving it, and then like trying to teach people my thought process, my working, like how we did today. How like I kind of just walked through it, how you're supposed to do the attack and all that. And then the next week after CTF week is all Code 4 and Sherlock, like bounty hunting type of stuff, where we read through old reports, talk about it, and another part I want to get to doing is like building. So like whenever I go to create something, like what is my thought process whenever I'm trying to create this smart contract? Because I think it's important for us, like as security folks, to be devs. I mean, you're obviously a dev and a security person, so you're good on that. But for like a lot of newbies coming in, I really think that they should be focusing on a lot on development too. So yeah, I'd be down to do some of that through these sessions.
So the good thing about this kind of tooling is that you can focus on solving the problem rather than trying to fight again the API of Web3.js or Ether.js.
Yeah.
Right? Because right now we spend some time to try to guess how to calculate the function selector for PWN.
Mm-hmm.
And if you have this kind of tools implemented on place, you can focus on really going to the problem instead of trying to fight
Do this
again the
stuff.
API.
Yeah. That's literally all it is. Because I feel like I knew the attack early on. Is just the is like actually going in and doing the attack. That's the fun part. Is like how do you set up the data? How do you set up everything? What's the
Yeah.
issue with that?
I don't know how far you went with Ethernaut, but at some point it gets really how can I say it? Really
Tedious, hard,
like there is one exercise where you have to create bytecode by hand.
oh, what? Which one is
I think
that?
can you scroll up a little bit? I cannot really remember what is the magic number. Go to magic number.
Magic number. I haven't done
A
that
little
one
bit,
yet.
a little bit up there, and that is where the point that you have to be yeah, right.
What? Raw EVM
The thing is,
bytecode?
right, you have to create a contract by hand that is so small that you cannot create that by writing Solidity code. You have to create it by writing literally. That is says that's right, raw EVM bytecode. So you have to be a EVM bytecode wizard, and that is where you mark the difference between some guy that is just writing contracts and a hacker, because you literally have to understand how the EVM
Works.
work, like, because it's a state machine where you have like this the no, not the heap, the memory, where you start stacking opcodes, and you have to know that there it is. You have to know the opcodes. Like, if you want to build the contract, there is a group of functions. There is a group of opcodes that you have to call in that specific order.
Hmm.
But when you write Solidity, it grabs up many things. But the challenge for that specific CTA is that if you try to do this by writing Solidity code, you are going to fail,
Mm-hmm.
You need to only go to the to the EVM bytecode and write this by hand.
That is insane. That's gonna
And
be
it's
a.
and it's insane.
But
You
I.
feel like a baby when you reach this level.
Uh-huh.
I I am a god. I can solve everything. But when you reaches this level, you realize that um, some vulnerabilities and some border cases were created just by someone writing some code, and he has bad luck that the EVM code has some kind of vulnerability because
Mm-hmm.
it is an unexpected border case.
Yeah, that is insane. I didn't even know that was one of the challenges. If you're, hopefully you're on the call for this one. But if not, I will definitely be looking at a write up for this and copying it and just learning from that. Um, but yeah, this is crazy. This is why CTFs are good for learning. Because these are things you just don't learn typically, like on the normal Solidity development track. You know.
Exactly, because in Solidity is the idea of Solidity, the main idea of Solidity is that it's straightforward code. Like it's way too simple to mess up.
Mm-hmm.
Like it's intentionally created to be simple because I don't know if these genius guys were uh, aware that even if you create a code as simple as Solidity,
Mm-hmm.
it's going to be complex. It's going to be complex anyway. Um, but there are some cases where you have developers of different platforms or different protocols that they actually need to write in EVM to save gas. And writing in EVM is like a leap of faith because you are you are bypassing all the Solidity uh, secure features that is implemented in place.
Yeah.
But yeah,
Yeah, no,
all right.
I couldn't imagine that. Actually, I forgot to close this
This was
out.
amazing.
Let's
And by the
submit
way,
this.
this guy Alejandro Santander, the author of this CTF, what
Do you know
he
him?
says in there. I don't personally know him, but he is lead developer at Synthetics. Synthetics. Um, he's he's brilliant. He created the thing to make us exercise, but I saw uh, one of his speech at DEF CON. He was speaking about proxy contracts,
Mm-hmm.
uh, and he's working today in synthetics and all these super massive and advanced and complex protocols. They really need
Is
to
this it?
go
Alice in Proxyland? This right, his talk right here?
synthetics. Yeah, right. That's it. That's Alice in
Yeah.
Proxyland. Yeah, he's working on synthetics. And there in that talk, he explains what are the difference between a one proxy and the other proxy.
Oh.
Um, of between proxies and k bits between proxies. And honestly, when you start to go in this down deep into the rabbit hole, you feel like a child. Yeah,
Yeah,
but
this is gonna definitely take some time, but it's one step at a time.
yeah, one step at a time. But we are doing great in here. All right,
But
man. I don't want to take more of your time and spend more of this conversation. I'm super happy to be here, and I'm super happy to see you that you are really working toward and having these sessions. Uh, Man, I cannot say anything else than I'm super proud of where you are today.
thank you, bro. I appreciate it, man. It's crazy because it all started, you mentoring me and helping me get here. So
This is what happens when you take the time to teach me and help me. So I'm just spreading it back to the community and making sure I teach other people how to get there too.
Right. I just gave you a starting point. You have the skills and you have the attitude and you have the you want to have this knowledge. And as long as I can support you, I'm going to be here, man. But I gotta drop to right now.
Thank you, bro. Same
Right.
here. Let me know. Yeah, no, let me hold on. Let me cut off the stream. I'm gonna end the stream.
Let me know when you have the next session. I'm going to be super proud of collaborating and being